Hello everyone, my name is Rajkot and my pilot is on finding an optimized sanitation system for peri-urban areas of city of Rajkot. Following the presentation structure, I would like to start with city sanitation assessment. Overall city has sanitation infrastructure with conventional sewer lines all over the 18 wards. But in Ruda, there is incompetence in sanitation value chain where sewer is conveyed through shallow sewers but the treatment and reuse of wastewater is not met. As mentioned earlier, the city is urbanizing at higher pace and the demand for infrastructure is ascending. This results into dropping of overall efficiency. As per SLB 2020, the city had 85% coverage of sewer network and collection of efficiency was only 59%. The graph illustrates the proof behind this. As population is growing, the city is expanding spatially, and with respect to it, the overall collection efficiency is decreasing. And more prone areas to these situations are peri-urban areas, where service is lacks. Now coming to problem tree, from our sectoral analysis has found that there is an issue of insufficient and unsafe sanitation, where the causes are rooted related to absence of sanitation in Ruda due to lack of strategy affecting the natural bodies where sewer is drained into, leading to mosquito breeding and poor hygiene conditions. The project aims to provide a safe disposal of sewerage by finding an optimized sanitation system for the peri-urban areas of the city. And the objectives are to identify cluster of villages which are more likely to be urbanized, to identify problems related to sanitation in Ruda, to assess different treatment technologies which could be adopted and implemented, and lastly to formulate a decision making tool. For ground truthing and to understand the sanitation characteristics of the villages, site study was done. Out of total villages, 40% of the villages have agriculture nature, followed by 40% residential and 12% industrial. The average growth rate of the villages is 2.8%, and the majority of them have huge urbanization potential. Further, for selection of site to conduct surveys, these four parameters were considered. After considering those parameters, five clusters were identified, comprised of 15 villages. All the clusters are listed as shown. The cluster darker than the lighter ones are more likely to get urbanized. To understand the situation of villages, total 150 surveys were conducted, 30 per clusters, and the aim was to understand the total sanitation value chain in the village. After the survey, it was found that each villages had 100% toilet coverage, which were connected to shallow sewer networks where sewer was disposed untreated. From 15 villages, 6 MLD wastewater was generated, and to upscale this data, Ruda generates 14 MLD. For treatment, with the help of few case studies, favorable treatment technology was identified, and few of these cost estimates are adopted for calculation for development of decision-making metrics. Looking at the existing scenario of Ruda, out of many, two scenarios are favorable where a decision can be made. Option 1 is where the potential clusters can be linked into the existing centralized system, considering the listed parameters. If not, then they can opt for new decentralized system. Clusters are identified on the map. Following parameters like distance from existing STP, cost for laying trunk infrastructure, topography, disposal option, reuse market have been taken considered for the decision tool. Depending on the data fed, the metric is developed based on favorable condition to identify the system. Cluster 3 and 4 were taken for the demonstration by using this tool. After analyzing all the parameters for cluster 3, the tool favors centralized system. Whereas in cluster 4, tool supports the decentralized system.